so here's the prototype of our game we're going to make. Not fully completed yet, but here we have our main player is going to be a sphere that rolls around. We are using the WASD keys to move around, or you could use arrow keys or even a controller. And we have a camera that follows the player as they move around with some settings that have a bit of a lag, kind of create a more interesting feel. We have objects that can be pushed around and objects that can't be. We have collectibles, so we have a coin type thing that we can pick up. I don't have the score implemented in the UI yet in this prototype, but that's where we're at. We're also going to set up a landscape. So we're going to set up our environment to use a tool that's in Unreal for landscape, where we have the ability to kind of create ramps and these dugouts, and we can actually even add in props and buildings and stuff on top of it as well. This is going to be a physics-based game, so our movement's all going to be based around making this ball roll around. The player's not going to have the easiest control. It's going to be physics-based, so as you roll forward, in order to stop and slow down, it's a little bit harder to change directions. Adding a bit of challenge to, like, you have to map out and plan your moves. The goal for this will eventually be to just survive and pick up all of the coins and not to fall in various traps that we'll be implementing, such as lava or hitting spikes or falling off the edge of the planet. So yeah, this is the early prototype version of our game. Let's get started. All right, so let's get our project open in Unreal and Visual Studio. First thing you're going to want to do is get your project in GitHub Desktop. Make sure you save that somewhere you can find it later. Then go ahead and click on Show in Explorer. Here you're going to see 5 files: config, content.ignore, .uproject, and a README. Now the file we really want to worry about right now is this .uproject. Go ahead and double click on that, and that will open up your project in Unreal. And you can see as it's doing that, it's creating a bunch of new folders. These are required for Unreal to work in the actual engine, but those don't get saved on GitHub. Right here, we have our basic level. This basic level is called Testing Ground. All it has is a ground and your atmosphere, your skylighting. If you want to, go ahead and take a couple minutes and set your light color and kind of get your project looking in the way you want to. You can change the rotation and, give yourself a sunset look and change the clouds and all that kind of stuff. Get it looking how you want it to. You can always change it later. Now, we're going to want to actually open this project up in Visual Studio. Well, how do we do that? Well, we need to convert it into a C++ project. And that happens kind of automatically, honestly. We're going to go to Tool, New C++ Class, and then we're going to create an actor. This actor is going to be for an item. Just make a generic item class that we can assign for a coin or a bomb or something later. Go ahead and click on Next. For class type, we can either be public or private. Public means it is included and other classes can see it and use it. Private means only specific things can. We'll set this one to public for right now. For the name, let's go and call this item. You can see where it's going to be saved to. We want to leave that alone. It is specifically going to be put into a source folder, and then it's going to be in a folder with the project name, public, and then item.h, and then item.cpp, 2 different files. We'll talk about that in a minute. Go ahead and click on Create Class. Once that's done, it's going to pop up with a project now includes sources. Click OK, then click Yes. This will open Visual Studio. Now, once that's done, go into Unreal and close it. Close Unreal. In your Unreal Engine configuration, click the refresh button. Arrow right there. Then it'll pop up with Visual Studio Integration Tool Status. Click Enable. click refresh again. And when it looks like this, you're good to go. These bottom two, we'll leave alone for now. We'll come back and change those later. Now, in the right-hand side in your Solution Explorer, you're going to see a bunch of files. We can ignore most of them. You can minimize all of those. Only ones we care about are inside this gains folder. You extend this out, you'll see source, and then here you'll see your project name, then private and public. 2 folders there. Item.h is inside the public folder, and item.cpp is inside the private folder. Let's go ahead and open up item.h. I'm going to go ahead and hit this little pin icon there. This pins it to the taskbar. I'll do the same thing with item.cpp, so I can easily get between them. Now this made 2 files for this one class. Why did it do that? Well, that's because it made a header and a source file. In C++, your code for a class is split into two different files, header.h and source.cpp. So the .h file is your blueprint or declaration. It's where you define the parts of it, while source file, the .cpp file, is the actual implementation. Unreal automatically makes both when you add a new class, so it's pretty easy to work with. But this separation helps the compiler and other files know what a class can do before knowing how to do it. Think of it like this. Your header file has the variables, your functions, and you declare what is going to be in that class. And other things in your game can see that. But by default, it can't see your source file. Your source file is where you do the actual logic. So for instance, you may have a function inside of a header file for jump. Other files can see that this enemy class can jump, but it can't see the logic for how it does jump. This makes it so you can't accidentally change something in your file you didn't mean to. It also makes them a lot more lightweight. Helps you organize your code. Yet you can have a large project and it's easier to read and maintain the parts because once you're done with your source file, the body, you may never need to actually go in and change it, but you may need to refer to the parts of it a lot. It helps with compilation speed as well. Your compiler doesn't have to recompile everything. It only needs to recompile what has changed, so you can build that part of your engine, and if you never change it again, all the better. It lets you reuse your code without having to know how it works as well. There's actually a key example here. In Unreal, we're using the actor class. We get access to the header for that class, but we don't get to see the source code. That's because we don't care how it works. We just need to know how to use it. In Unreal, C++ file, the .h file rather, tells Unreal what properties and functions are exposed to Blueprint. This is where we see the ability to connect files together. Meanwhile, your .cpp file will have the actual code that makes the logic work and makes it run. We'll see what that means in more detail. Hopefully it will be clear in a little bit. Now back on Visual Studio, our item.h. What are the parts of this? What's in here? Well, here we have a comment, line 1, about filling out a copyright notice in the description page and project settings. You can set that up if you want to in Unreal later. Then we have this pragma once. This is a simple little thing that makes it so we can't add in more items like this. Then we have some include files, include core minimal.h and include game framework /actor.h. This right here, these 2 things right here, are calling and referencing rather these header files, these .h file. So somewhere in our engine is a file that says core minimal or one that says actor. In fact, we can actually view what this is here. If I go down here, I have this public A actor. If I right click, I can view definition. And this opens up the code for an actor in Unreal. Right there it says tooltip. An actor is an object that can be placed or spawned in the world. Cool. And it is a blueprint type, and it's blueprintable. And so we have information about it, which is pretty cool. And you can see all the different things it can do, or things it has. Now, we don't really care at this point what any of this does, and we certainly don't care how it does it, right? But we can see that we have get runtime grid, get actor GUID, things like that. The perk of working in this sort of structure is we don't need to know how this works. You can see what it does. I'll close that out now. The next line of code we have is this include item.generated.h. Now this right here is a tricky one. This is a special generated.h file that is created when we compile. This always needs to be the last include. So if we add more include files, we are going to want to include them above there. We will soon, just not right now. Next, we have this U class. This is a macro, which we'll talk about what macros are a little bit later, but it's a special set of code that is used by Unreal to define this as a class. It wraps the basic C++ class in a special structure using this macro. This is because all C++ files tend to work with a .h and a .cpp file, but we want to have extra functionality inside of Unreal. Now we have class, and then we have a reference to the project, CPP Rollerball Start. That's the project name that I'm on. Yours might be different. Then a item. Wait, no. I call this item. I call the class item. Why does it say a item? Well, that's because Unreal added that a there in front of it. If you had to take a guess, what does that a stand for? What's the prefix for? Well, if you guessed actor, you'd be right. This is a shorthand saying, hey, item is an actor. Nice and easy. And it added that for us automatically. Then we have this colon and then public A actor. This is a way of inheriting the actor into our item. So we get access in item to all the code that actor has. And we'll be using this ourselves later when we make different kinds of items. But for now, just leave that line of code alone. Here we have a macro for generated body. This is referencing the stuff that's inside of this item.generated.h that we don't ever have to worry about. Just leave this line of code alone. Below there, we have three different functions. A item, which has no return type because this is a default constructor. We'll talk about what that is later. Then we have virtual void begin play override. Well, this begin play part should be familiar to you. That's because there's an event begin play in Blueprint. And then virtual void tick override. This is another function we actually have access to in Blueprint that's called every frame. And these are given to us by default. What these virtual void, protected, and public, what all those mean, we'll get to later. Next, if we go to our item.cpp, we can see, all right, well, there's a item, which this sets default values. And oh, there's begin play. So we define begin play in our header file, and we implement begin play in our source file. And then the same with tick. Now, super means that we'll talk about a little bit later, but really it's just saying call whatever actor has in begin play and then do this stuff. That's all that really means. All right, so we're gonna file and save all, make sure everything's saved. let's go ahead and compile this and run it. Now, at the top bar, you should see a green play button that is not filled in. If you click on that, this is going to compile your project. First time you do this is going to take a minute. So give it, until it's done. You'll know it's still working because this icon down here on the bottom is still going to be running. All right, so my Visual Studio is still open, but it opened up Unreal. Inside this content drawer pop-up, it shows C++ class. And I expand that out, go public, and there we go. There's our item class. If I close the content drawer and I go to this bottom content drawer, unfortunately, that folder's not there. It's not showing up for us. This is a bug in Unreal that's been around for a while. It's easy to work around though. In the top right-hand corner, you should see this dock in layout. Click on that. And there we go. That docked the content drawer to the bottom of our screen. So now it's always there. And there we go. We have our item class. Now you could drag this item class into our scene, and I'm trying to move it. It's not letting me. That's because a C++ class doesn't have a transform or anything on it, by default at least. So we can't actually work with just the C++ class. We need to create a blueprint from it. To do so, let's go to our content drawer, right-click, new folder, call it Blueprints, open that up, right-click, Blueprint class, and then the parent class. For this, let's go to All Classes, search for Item. There we go. We can make a blueprint from Item. Hit select, we'll call it BP_item. I'm going to go in here and I'm going to delete this item that is in my scene from the C++ class. I'll delete that. And I'm going to drag this blueprint class in here. And now, there we go. We can move this around because this blueprint can exist inside of our scene. It has a transform. It has all that stuff attached to it. So we can actually work with it. I'm going to go to File and Save All and save that. And we'll worry about actually adding to something in the next video. For now, we've already made some progress. Now, make sure when you're done, you File, Save All, save everything. Make sure Visual Studio, everything is saved. Then go to GitHub. And you're going to see your changes that you've made. Go to Summary. In here, you're going to write in finish video 1. Then click Commit. And push. Make sure you're doing this regularly, using your version control to back up your work, because you don't want to lose your work.